Dear students, I welcome all for this session. In our previous session, we have discussed the various sorting techniques like bubble sort, selection sort, insertion sort, and merge sort. Today, we are going to discuss one more sorting technique called quick sort. As like merge sort, quick sort is also based on divide and conquer strategy. Let us look into the methodology that we are going to use it for sorting the list using quick sort. The basic concept of quick sort process is to pick one element from the list, that is a one-dimensional array, and rearrange the remaining elements around this. Here, the chosen element, we call it as the pivot element. So given an array, you have to first pick one element from the array. Once pivot is chosen, then we are going to shift all the elements less than the pivot to the left side, and all the elements greater than the pivot are shifted to the right side. The pivot elements, now we are going to use it for dividing the list into two sublists. And this process of choosing the pivot and partitioning the list is applied recursively until sublists are consisting of only one element. Since quicksort is based on partition, it is also known as partition exchange sorting. This diagram illustrates the basic concept of quicksort. Here in the list, I'm going to choose the first element, that is 8 itself, as the pivot element. You can choose any element, but for the sake of simplicity, I'm choosing the first element as the pivot element. After choosing the pivot element, we are going to shift all the elements which are lesser than the pivot to the left side of the pivot, and all the elements which are greater than the pivot, that is greater than 8, to the right side of this pivot element. After rearranging the list, now we are going to partition the list into two halves. Okay, the left half will be having the elements which are lesser than pivot, and the right half will be having elements which are greater than pivot. And now we will apply the same process, that is choosing the pivot and rearranging the elements is applied recursively on these two sublists until the list contains only one element. Okay, now let us look into the algorithm. The first step in algorithm is to pick an element called pivot from the list. Here we are choosing the first element as the pivot element. And after choosing the pivot element, you are going to reorder the list so that all the elements which are lesser than the pivot comes before the pivot, and all the elements greater than the pivot come after it. If there is any element which is equal to the pivot value, then you can move that element either to the left or to the right of the pivot. After this, you're going to partition the list into two halves, and the pivot will be in its final position. And this is called as partition operation. Next, we are going to recursively sort each sublist, a sublist of lesser elements and sublist of greater elements, by applying these two steps, step 1 and step 2, recursively. The base case for the recursion is a list with 0 or 1 element. Obviously, a list with 0 or 1 element is a sorted list. Let us now discuss quick sort technique with an example. Here I have considered a list with the elements 8, 3, 2, 11, 5, 14, 0, 2, 9, 4, and 20. You can choose any element from this list as the pivot element. For the sake of simplicity, I am choosing the first element itself as the pivot element. After choosing the pivot element, next you have to rearrange the remaining elements around the pivot element. In the next step, you are going to search for an element which is lesser than the pivot element from the right side of the array. So when you start your searching operation for an element which is lesser than 8, you can see here an element 4 is lesser than 8. Hence, you are going to swap these two elements. That means in place of 4, you are going to write 8, and in place of 8, you are going to write 4. Okay. In the next step, you are going to search for an element which is greater than the pivot element from the left side of the array. Okay. So here you can see an element 11 is greater than 8. Hence, you are going to swap these two elements. So at the end of this step, you will find 11 to the right side and 8 is placed at this position. Okay, after swapping 11 and 8, the list will be this: 4, 3, 2, 8, 5, 14, 0, 2, 9, 11, and 20. At every step, you are going to search for an element from the right until you find an element which is lesser than the pivot element. Once you find the element which is lesser than the pivot element, you are going to swap the pivot element and the smaller element. After that, you're going to start your searching operation from the left side until you find an element which is greater than the pivot element. Once you find an element greater than pivot, you are going to swap the pivot element with the greater element. That is one step. In the next step, you are going to repeat the same process. Now you will start your searching operation from the right side for an element smaller than the pivot element. Here you can notice an element 2 is smaller than 8. Hence, you are going to swap these two elements. At the end of the step, the list will be this. And now you are going to start your searching operation from the left until you find an element greater than 8. Now you can see when you search for an element greater than 8, here you have found the element 14. So now you are going to swap the pivot element with the greater element. So 14 goes to this position and 8 comes to this position. Okay. And now again, in the next step, you are going to repeat the same process. Now you are going to start your searching operation from the right side for an element smaller than the pivot element. So here you have found an element 0, which is smaller than the pivot element. Now you are going to swap these two elements. 0 comes to the left side of 8 and 8 goes to this position. After shifting 0 to the left side, you can see all the elements to the left of the pivot element are smaller and all the elements to the right of the pivot are greater. Now it is time for partitioning the list. After partitioning, you will find two sublists. So one sublist with smaller elements and the other sublist with the greater elements than the pivot element. Okay. Now on these two sublists, again you are going to apply the same process. Let us first consider the left sublist. On this left sublist, again you are going to choose the first element itself as the pivot element. After finding the pivot, you are going to start searching for an element from the right side until you find an element smaller than pivot. Hence, you are going to swap these two elements. Now 0 comes to this position and 4 goes to this position. And now you will start your searching operation from the left side for an element greater than the pivot element. Here you have found an element 5, which is greater than the pivot. Now you are going to swap the pivot element and the greater element. So 5 goes to this position and 4 comes to this position. Okay. So now the position for the pivot element is fixed. Again, you're going to partition the list into two halves. You can see all the elements to the left of this pivot element 4 are smaller and the element to the right of the pivot is greater than the pivot element. Okay. Now you are going to repeat the same process. You are going to divide the list into 2. And on the left sublist, again, you're going to repeat the same process, that is choosing the first element as the pivot element. And you will start searching for an element from the right side for an element smaller than the pivot element. There are no elements which are smaller than 0. Hence, you will start searching for an element which is greater than 0 from the right side. Even from the right side, you will not find any element because 0 itself is in the first position. Okay. Now, this 0 is in its exact position. Now you're going to divide the list into two halves. The left half will be the list with no elements, and the right half will be having the elements 3, 2, 2. Okay. Now on this right half, again, you're going to repeat the process. You will choose the first element 3 as the pivot element. And now you are going to search for an element from the right side until you find an element smaller than the pivot. Here 2 is smaller than pivot, hence you will swap these two elements. 2 comes here and 3 goes here. After that, you will start searching for an element from the right side until you find an element greater than 3. So there are no elements greater than 3, hence the position for this element is fixed. Now the left half will be having the elements 2, 2, and the right half will be having no elements. Okay, again you will apply the same process. So after applying the same process, the list will be 0, 2, 2, and 3. And here the right half of this pivot element 4 will be having only one element. A list with only one element is already a sorted list, hence we are not going to perform any operation on this list. Now you have to concentrate on the right half of this list, list with the elements 14, 9, 11, and 20. I'll choose the first element 14 as the pivot element, and I'll start my searching operation from the right until I find an element smaller than pivot. So here 11 is smaller than 14, and hence we are going to swap these two elements. 11 comes here and 14 goes here. Next, you will start searching for an element from the left until an element greater than pivot is found. There are no elements greater than pivot. Hence, you are going to divide the list now. So then the left half will be having the elements 11 and 9, and the right half will be having the elements 20. Again, you will repeat the same process. At the end of the iteration, you will get this list, that is 9 and 11 and 20. Now you can see all the elements are in its proper position. So 0 is the first element, then 2, after that 3, then 4, 5, then 8. After 8, it is 9, then 11, 14. After 14, the last element 20 is in its proper position. This is how the quick sorting technique sorts the list. Because it sorts the list much faster when compared to other sorting technique, it got the name quick sort. Here is the C program segment for quick sort function. So this function accepts 3 parameter, a list, which is an array, and then the lower index of the array and the higher index of the array. Initially, I'll choose the first element. Initial value of low will be 0 and the initial value of I will be n minus 1. Initially, I'll choose the first element, that is A of 0th element as the pivot element. And next, I'm going to use two pointer variables called I and j, and the values of these pointer variables are mentioned here. I value will be set to low plus 1 and the j value will be set to high. We have discussed in our previous slide. In each step, we are going to find an element which is greater than pivot and also an element which is lesser than the pivot. To find an element which is greater than pivot, I'm using this pointer variable I, and to find an element lesser than the pivot, I'm using this j pointer variable. So the j pointer variable will start searching for an element smaller than the pivot from the right side, right? So hence I've set this j pointer variable to high. And this high pointer variable will start its searching operation for an element lesser than the pivot from the left side. Hence, I've set this I pointer to low plus 1. Okay. After this, I'm going to check whether the value of I is less than j. If it is true, then I'll just check whether this pivot element is greater than E of j. If the pivot element is greater than A of j, that means you are you are having an element which is smaller than the pivot element. In that case, you are going to just increment your I pointer. If the pivot is greater than E of j, you're going to increment the I pointer. If the pivot is lesser than E of j, you're going to decrement your j pointer. Okay, so when an element which is smaller than the pivot is found, this looping statement is going to end. The position of the j will indicate the position of the smallest element in the list. Similarly, here also, if an element greater than the pivot element is found, the j pointer will be incremented and the position of the j pointer will point to the position of the largest element in the list. After finding the position of the smaller and the larger element, you are going to exchange the elements, that is swapping operation. Okay, if there are no element which is greater, or if there are no element which is smaller, then you are going to simply skip this process. Okay, the pivot element will be placed in that position itself. And at last, you are going to swap the A of lowth element with A of jth element. Okay, you are going to swap A of lowth element with A of jth element, and to this A of jth position, you are going to place this pivot element. Okay, and after fixing the position of the pivot element, next you are going to divide the list into two halves. Okay, so again you are going to call this quicksort technique on the left sublist as well as on the right sublist. So we are passing the two separate list again into this quicksort technique. The left sublist will be having the index value low to j minus 1, and the right sublist will be having the index value that is j plus 1 to high. So this completes the function for quicksort. And coming to the performance analysis, the best case and the average case performance of quicksort is n log n, but the worst case performance is order of n square. And coming to the space complexity, quicksort takes order of n space, that is to store n elements, it is going to consume n memory location. Hence, the space complexity will be order of n. And this completes quick sorting technique. Thank you for your patience listening.